Hello, everyone, and thanks again for tuning in to the Multi-Chain Infrastructure Summit. Continuing on the day, we do have a deep dive with one of the leading ZK rollups of the Ethereum ecosystem, of course, zkSync, that has come a long way and has a long history of contributing to the Ethereum scaling infrastructure. With us, we have Marco, who is the head of BD at zkSync, and therefore has been responsible for growing a lot of adoption here and has been exposed to a lot of the evolution of how zkSync has come to where it is today. So, Marco, it's great to have you.
Super nice to be here.
All right, let's jump right in and kick off with a quick introduction of yourself. And we'd love to hear the story of zkSync. I know it's a pretty long story, from version 1 now to version 2 and all the traction that we've been making so far.
So quickly about myself. My name is Marco. I'm the head of business development for zkSync. I've been the second non-engineering employee that joined almost 1.5 years ago, and has been an amazing ride so far. Before this, I was the CEO of the Asia portion of a global fund management company. And before that, I was a quantitative analyst doing models for hedge funds about pricing derivatives. So the story of zkSync, I think it's actually a pretty straightforward, actually quite short story. So what the two Alexes saw, the vision was that if blockchain was meant to be successful, then scaling would have been a major problem. And so 4 years ago, they embarked upon this problem and very quickly stumbled on zero-knowledge proof, which at the time were totally not ready to support production environments. But they saw in it the only possibility to solve the scaling trilemma. And so what is zkSync, what is MetaLab trying to do is exactly this, is solving the trilemma. Today, if you want to achieve scale, you have to sacrifice either decentralization or security. And unfortunately for us, this is a choice that you kind of cannot make, because if you sacrifice either security or decentralization, you typically tend to eliminate one of the core fundamental value that comes with blockchain, that otherwise becomes a very expensive database with some nice properties, but usually not enough to justify its adoption. So without decentralization or security, the system tends to be not very useful. And the problem is that with the decentralization and security, you couldn't make it scale. And the problem with that is that the blockchain is trying to do too many things at the same time. It's trying to provide too many properties all within the same system. And what we are doing at MetaLabs here, essentially modularizing it. So we are separating the execution environment from the environment that provides security and decentralization. And with this trick, we are able to then have two environments that are optimized to do two different things, and you can achieve all the three properties at the same time.
Awesome. Of course, to replicate the functionalities of Ethereum and EVM has been quite a journey to build this zk EVM, right? Which is then, as I understand, the version 2.0. So shall we also talk a little bit about the evolution from the 1.0 to 2.0 and the current progress we've seen?
Yeah, so very, very smart people, much smarter than me, proved that you can create a zero-knowledge version of any problem. And so the very first tentative to use zk to scale blockchains were all centered around taking a problem and making a version of that problem that was faster and more performant, preserving the security of Ethereum. Now, this approach was done independently by the friends at Starkware with StarkX and by ourselves with zkSync v1. We took two different approaches, trying to do two different things. So zkSync v1 in particular was focused on a special purpose infrastructure that was designed to do very efficiently transfers, atomic swaps, NFT minting, and also a bunch of other functions that are necessary for the functioning of the system, like deposit withdrawal, meta transactions. This infrastructure has been the first zk rollup that was ever deployed, has been running for more than 2 years, did millions of transactions with a very, very high uptime, and has been working very well ever since. The problem with this approach, though, is that it's not general purpose. So it's extremely involved, the process of taking a problem and converting it in something amenable to zk proof. What we all wanted, the gold, the gold mine in crypto, is to create a more performant version of Ethereum itself, which is what a general purpose zk rollup is, and is what zkSync v2 is at the moment. There were a lot of innovation that led to that, and eventually, a couple of years ago, we set on the current framework on which we have been working for 2 years. We opened testnet for zkSync v2 at the very end of last year, on the 27th of December. We then opened it to the general public in February. We have been in testnet for a long time. We deployed in mainnet a little bit more than a month ago. We are still closed to allow for proper security checks. We just finished the first security audit. We are performing quite a few more. We are doing bug bounties. We are doing everything that is in our power to make the system secure. And very soon we will be opening it to our partners and the projects that have registered for deployment. And then roughly a month later, 4 to 6 weeks later, we will make it permissionless and open it to the general public that will be able to start to use it. So far, we have been having a great traction. We are blessed from a lot of attention. I think the key reason is the fact that while there is a general agreement that zk rollup is the future of scaling for blockchains, there is also a general agreement that EVM provides the path of least resistance for the infrastructure to move. And at the moment, zkSync is the only zkVM that is live on mainnet, and that is about to be open to the general public. So we are very, very excited. We have an extremely large ecosystem that announced its intention to deploy on zkSync. We have on our own page, ecosystem.zkSync.io, a place in which projects register themselves. There is a little bit less than 200 projects, I think 197 as of today, so almost 200 projects. So you can see a big breadth of the ecosystem, but you can also see a nice depth. So all the verticals within crypto are represented. So we have a nice representative in DeFi, in NFT, in games, but also identity, privacy, in the infrastructure space, in wallets, on-ramps, centralized exchanges. So there is a very strong ecosystem that is being formed. And many of the key players on layer one have also already committed to deploy. We went through governance approval with Uniswap, with Aave, the other day with Hop. We did a proposal to MakerDAO. We are proposing to a lot of large projects, and so far we are receiving a great response. Balancer, Curve, Yearn, 1inch. So all of these teams that produce great products are all working on a deployment. And on the NFT side, we're also having very, very interesting conversation with many large marketplaces like Taker, like Tofu, like Mint Square, that are all deploying or are already deployed on our testnet. So we feel very, very good about the ecosystem. Is very strong, and it has all the critical component that will allow our users to enjoy it.
Awesome. Yeah, it's super exciting to see the mainnet launch and the quick adoption that all these developers have moved over to try out this new environment. And I think that comes with, as you've mentioned, like the benefits of like the scalability and the cost benefits of like zk, and also with the developer friendliness of like being a zk EVM, and therefore they can use Solidity, which they are already familiar with. At the same time, I think you're definitely familiar that Vitalik has put out a comparison kind of like article about the various types of zk EVM, right? So while zkSync is a first mover or early mover, there are many other implementations that are trying to do it in a different approach, from like a fully Ethereum equivalent to like replicating exactly EVM equivalent, or we're looking at in zkSync's case more of like Solidity like compatible, so that you can use the same language for the developers. Do you kind of agree with this characterization? Like, are the differences, magnified is really not that different in the end game? And, why has zkSync chosen to go down this path?
Yeah, so we broadly agree. Maybe What I would like to say also is that we are all working towards making the system as EVM compatible as possible. So there will be innovation over time that I'm sure will be done by both ourselves and some of the other teams that are doing a wonderful job in the space to move as close as possible to the maximum degree of compatibility. I think the space is, the dichotomy can be expressed in terms of performance and compatibility, and which, I'll try to answer also the question on why we chose this approach. We think is the most pragmatic approach. We think both performance and compatibility are both necessary, non-sufficient condition for success, for being an optimal development environment for projects that are using the technology. And so if you plot them onto the spectrum, you have two clear choices. One is ignoring compatibility completely, going for performance. You develop your own programming language, and that's the path the Starkware has taken. And I know you guys are speaking with them as well in this panel, so they'll probably do a much better job than I could ever do in explaining what they're doing. But the idea is that they will go for performance. They are ignoring compatibility for now, although they're working with partners like Kakarot and Warp to actually bring some form of support for Solidity. But in general, the focus is on performance. On the other end of the spectrum, type 3, although there are different types of types 3, but so the friends at Scroll, the friends at Polygon will again be able to explain better what's the differences between them. But in general, they will be very similar. They are trying to aim for EVM equivalence, so identical infrastructure to Ethereum, apart from gas metering and a few other bits and pieces. So very high degree of compatibility that will come at the big cost of performance. And so we will need to see once they develop, once they deploy in practice, what this cost is. But in general, I think there's a general agreement that is going to be quite a significant cost of performance. Our approach is an intermediate approach. So we went for language level compatibility. So we are compatible with Solidity, which means you get Solidity, you get EVM, you get the tool chain, you get all the developer tools. So you get a lot of stuff out of the box from this compatibility. At the moment, the degree of compatibility is very, very high. We don't support 3 opcodes, but one is self-destruct that I think last week was enlisted among the one that are going to be removed. And the other is called code that also is going to be deprecated in favor of a newer opcode. So in reality, in terms of language compatibility, we have an extremely high degree of compatibility. And because we use LLVM in the background, which is one of the most developed compiler infrastructure, we feel we'll also have an extremely high degree of performance. Again, we are all about to go live on mainnet, so we will actually be able to measure this information. But we feel we will be as performant, if not more performant than Starkware, and we will be almost as compatible as the EVM equivalent zkEVM. When they will become live. Also, our approach allowed us to be relatively fast to market. And there is a couple of other aspects that I think are interesting. So when you are EVM equivalent, you are aligning your roadmap to that of Ethereum, which may not be super desirable because the Ethereum roadmap is designed for a system that has billions of dollars in assets. And so it's rightfully slow and careful. And while rollups are all small and we should be nimble and agile, and I don't know that you want to align yourself with Ethereum in terms of roadmap. The other aspect that is maybe less obvious is that if enough users migrate onto rollups, and so if the execution layer starts to take over, then Ethereum will stop implementing user-focused EIPs. One key example that comes to mind is account abstraction. So account abstraction has been discussed in context of Ethereum for maybe 4 years now, Paymaster for a couple of years, and they are not implemented. And so if you go for EVM equivalence, you may have an issue if this never gets implemented. You may have to deviate a little bit from this EVM equivalence narrative. Our approach allows us to be pragmatic. And so while we are trying to be, say, we are missing one opcode out of 140, so say we are 99.5% compatible at the language level with Ethereum, we are 100% compatible with what the future of Ethereum should be. Account abstraction, I think Vitalik wrote extensively, should have been there for years by now. And we think is essential. So things like account abstraction are absolutely essential for the adoption of the next 2 billion people. Because let's face it, today, most of the users of blockchain are people like me. They're nerds. They're people that like to tinker and understand how things work. But we are not maybe like you as well, we are not representative of the average user. The average user wants an experience that is like HTTPS. When you're using SSL in your browser, you don't know what's happening in the background. You don't need to know. Everything that is complicated has been abstracted away. You just know, my mom knows that if she sees HTTPS, the thing is reasonably safe, and that's it. And that's as much as she's aware of what's happening. And account abstraction allows similar things to happen with private keys, with transaction, with gas fees, with a lot of things that today are a big hindrance to adoption. So we feel that this is an interesting compromise to make. So rather than being totally 100% equivalent, is interesting to be, 99% backward compatible, but 200% future compatible.
Absolutely. Yeah, we're also super excited about account abstraction, right? Where you don't need to think about private keys or gas, right? Just use your email, like free transactions. So of course, it's paid for by whatever products and services that you might consume. I really love the way you phrased it, which is you might not be compatible with the current version of Ethereum, but you'll be fully compatible with the future version of Ethereum. And so that is such a clear kind of like statement that actually I do wonder, then what kind of like developers or applications do we attract, right? And how is that different from these others? So if we're trying to offer these like more innovative mechanisms to cater to like the forward-looking developers and the users, is there a space then for these other types? Like what kind of niches do they fill when you look at like Starkware with like Cairo and like you say, focus on performance, or with like the more conservative like fully Ethereum or EVM equivalent type implementations? What kind of niches do you think they will occupy?
So, and I think the market will tell us. And again, next year is probably the year of zk Rollup, where we will all come online live, and the user will vote with their feet, with their wallets. They will show us what they prefer. Our bet is that the average developer on one end will want to be able to use 99% of the tool that they come to use today. And so that makes it very difficult for someone to decide to jump onto Starknet, because you will have to work out how to deal with a bunch of libraries that don't exist. You will have to work out how to do deployments, because Hardhat doesn't support it. You will not have the graph, and so you can't rely on those infrastructure. And at the beginning, you will not have a lot of those things that as a developer you are assuming they are there available for you to use, and you definitely don't want to redevelop from scratch. You don't want to recreate the entire infrastructure. You would just like to be able to use it as you are doing it today on Ethereum. And so that's the advantage that zkSync will have in that respect. Vis-a-vis the Type 3 zkEVM guys, so Polygon and Scroll, I think there is an aspect of also time to market. So we are going to be live very early next year to the public. We are already on mainnet. We went through a very long and extensive process of security, which we feel is absolutely necessary to be realistic and to be careful with the assets of our users. And so one key advantage is that we will be available for a good portion of next year, while many of the Type 3 zkEVM will not, unless they are willing to take some risk and deploy when they have not gone through as much testing as we have gone through, and or they maybe should go through. Again, they may be just better at developing and don't need to do this testing in the first place. So this, I think, is going to be the niche on the other side. Vis-a-vis the zkEVM, so the EVM equivalent zk Rollup, also the fact that we will immediately have all those future feature that Ethereum should have already today. So account abstraction at the base chain, we think is essential. As we said before, paymaster, so the ability to play with fees and who pays the fees and in which tokens these fees are paid, we think is extremely interesting. They open up a bunch of interesting design. You can now charge for flat fees, and so you can make something that looks and feel very much like Web 2. So recently there was all these conversations about FTX. FTX is really a Web 2 company that camouflage like a Web 3 company, while what we should be doing as an industry is the opposite. We should take Web 3 and camouflage it it in a good sense as Web 2, in the sense that Web 2 has great UX. We should learn from that and try to learn as much as possible from that UX by using Web 3 as a backend. And that's exactly what zkSync is aiming to do. We are trying to make all the innovation that it's possible to make sure the UX and the design space for better UX is available to our partners when they come and deploy on zkSync.
Absolutely. And so one of the aspects of having great developer experience is to be able to customize their own user experience for whoever they might be serving, right? So that they can, for example, choose to keep the data in somewhere or choose like the gas experience that they have. And to understanding part of like how we want to achieve this is that we have this idea of like validium and volition where data availability is handled in a different way. We have account extraction on layer 2 where we can look at different paymasters for gas and so on and make the account itself programmable, right? You have like fail safes, recovery. And beyond that, one level up for customization actually is the idea of layer 3s. Which I know zkSync has been talking about with the idea of like hyperchains, right? Where you have your own kind of virtualized environment where you can customize even further. And also this seems to be a convergent idea. We've seen other layer 2s talk about a similar thing with like Optimism Bedrock, with like the fractal scaling of Starkware. So I would love to hear your view of like how this layer 3 is gonna play out, right? The next step after like all these layer 2s have been launched.
Yeah, so layer 3 we think are an extremely interesting design space that is orthogonal and can be mixed with the other things you mentioned. So you can create a layer 3 and you can instantiate it as a rollup, as a validium, as a volition, or as we call it, zk porter. You can mix and match these designs. You can go multi-level, so you can do layer 3s, but you can also do layer 4s and so on and so forth. So there's going to be very interesting design that our partners will come up with. I'm in love with the emergent nature that blockchain has, the fact that the new things are always bigger than the sum of the parts, and so I'm super excited to see what people will use this technology for. So in general, what is a layer 3? What is an hyperchain? From a very, very abstract, simplified level, a layer 2 is just a layer 1 smart contract and a bunch of servers. You copy the servers, you deploy the layer 1 smart contract onto the layer 2, and ta-da, you have a layer 3. Why this is useful is because you get a little bit of boost in scaling, which is always nice, but it's probably not the most interesting thing. The second is because you can launch many of them in parallel with each other. So now you can start to create a system that scales linearly with the computing power. You have a system that starts to scale parallelly rather than vertically. And this is very, very interesting. Blockchain starts to behave like traditional computer infrastructures where if you're Google and you have 1 million users, you buy 1,000 servers. But if you have 10 million users, you buy 10,000 servers. It's very little overhead on top of just linear scale. And that's going to be very, very, very important. And number 3 is because you can customize very heavily these layer 3s. So once you have a layer 3, you can choose how many validators you want to have that will have consequences in terms of latency of transaction confirmation. So in zkSync, we already have in V1 sub-second confirmation. So the UX is already like Web 2 from majority of users. You don't have a perception that something is happening in the background once you click the button. But it's not suitable for high-frequency trading, for example. So if you are creating a DEX that is designed for high-frequency trading, you may want to make a compromise, lower the number of validators in the layer 3 and achieve a very, very low latency. You may want to play with the data availability to achieve privacy. You may want to do these two things at the same time. You will have a lot of design that you can use to customize the layer to the specific need of the application. So in general, we are very excited because we think layer 3s are the answer to both the dApp chain story. So I personally don't think that the dApp chain story as it is panning out today, which is a lot of alternative layer 1 for each application, is really sustainable long term. And there's a bunch of reasons, but the two biggest ones that are really fundamental and difficult to solve are, one, that once you have an alternative layer 1, you always need to have a bridge back to Ethereum, because that's where the action happened. That's where the product market fit seems to be at the moment. And so that bridge will necessarily fundamentally be native. And so as a development team, you will probably need to spend 20, 30, 40% of your time figuring out how to secure the bridge, because a breach in the bridge is a big problem. No, and we saw this happening over and over again. I mean, half of all the money lost in contract, smart contract tax and manipulation came from breaches over the past few years. And so that's, I think, painfully obvious to everybody. There's a big problem, and that I think is fundamentally unsolvable. You can't take care of forks, for example. There's a bunch of reasons why this is going to be always a problem. And the second is that in a proof of stake system, your security is strictly proportional to the FDV of your token. So if you have your own space, you need to secure it. If you use your own token, it's extremely difficult to justify what kind of level of security you are getting in an alternative layer one. The good thing of layer 3 is instead is that they strictly inherit the security of the layer below them, which is layer 2, which strictly inherits the one of Ethereum. So you are as safe with Ethereum, and you can have thousands of them on top of it, and they will all inherit the same level of security. And this is very, very, very cool. So on one end is an answer to the dApp chain. We don't think dApp chain are sustainable. I don't think dApp chains are sustainable long term, and I think they will all fall back onto layer 3s. The second is an answer to private chains. So we had Hyperledger, Corda, R3 talking about private chains to enterprises. And usually the reason why enterprises are looking into that, some reason are not very good. Like they think that they are a good place to test the technology, so then they can go on a public blockchain. This I think is not a good reason, because private blockchain are non-adversarial, public blockchain are adversarial. So it's like, me and you playing with, say, boxing for 5 minutes, and then I go and fight with Mike Tyson. Probably it's not going to work very well. So that's not a good reason to do your private chain. But there are good reasons. Like privacy is a great reason. For many companies, it's just impossible to use the blockchain because it's public, and they have to subject themselves to GDPR and a bunch of other regulation that makes it impossible for them to use it. So layer 3s are going to be a perfect answer to that conversation too, because you strictly inherit the security of Ethereum. This means that chain, especially in the context of zk Rollup, because of validity proof, would be credibly neutral. And so as a chain that is credibly neutral, you'll be able to scale it. One of the big problems of private blockchain is that if you are company A, typically, you don't want to use company B's blockchain just because it's company B's blockchain. There is no other major technical reason. You just don't want to use someone else's blockchain because it's not credibly neutral. And so they don't scale. Everybody needs to have his own blockchain, and my own blockchain is not useful. It's like my own telecom company is not useful. And so what you want as a telecom company is to speak with other people, and blockchains are networks. So you want to connect with other companies. But until they're credibly neutral, you cannot do that. And because the combination of Ethereum security and censorship resistance plus the validity proof, you will instead achieve a very high degree of credible neutrality that will make it into a level playing field that multiple enterprise may want to actually use to collaborate. If you couple that with zero knowledge proof used for privacy, then you have a very interesting design that allows for coordination under zero knowledge that I think is going to be very, very powerful long term in sucking in the blockchain world a lot of large enterprises that will find wonderful use cases to use the public blockchain that we all share.
Absolutely. And like you said, bringing in like institutions and like people who want their own chain. One area actually that we can also invite to then also synergize with what we're building with layer 2s is other zkSNARK kind of use cases, right? Because now I think a lot of the recent use cases we're talking about that involve like privacy, identity, and voting and so on use zkSNARKs in one way or the other. And can those also make use of the infrastructure that we're building?
Absolutely. So zk Rollup are an ideal place for snark-based applications. So as you mentioned, people are discovering zk proofs for many use cases. We are not really using it directly because we are not hiding anything. If you want, we are hiding computation with zk Rollup used for scaling. But you can do a lot of interesting things with proof of validity in many spaces. So proof of computational integrity are useful not just for scaling, but for many other purposes. And then for privacy. So privacy is going to be a hugely interesting and maybe controversial use case of blockchains. The good thing is that verifying snarks on layer 2 is very, very cheap. And so that means that they are an ideal place to deploy anything that has to do with snarks and with zero knowledge. So layer 3 are a good example of this, where verifying so the witness that verifies the validity of the execution of the layer 2 on layer 1 actually is quite expensive. So it's hundreds of thousands of gas and even millions of gas for Stark proofs. And so that's quite expensive, and it's going to continue to be expensive because Ethereum gas fees, in my opinion, will continue to grow with the adoption and the usage and the demand for security. Verifying the same on layer 2 is instead a fraction of $1, and that, so the difference in cost is gigantic. And so applications that rely heavily on snarks will become feasible on layer 2 that were instead impossible on layer 1 before.
Awesome. Yeah, I think so far we've built up such a strong case for this Ethereum rollup-centric roadmap, right? And how all these layer 2s will support both like general kind of applications, EVM developers, and also now like all these ZK use cases, private use cases. I do wonder now, can we zoom out a little bit further to then think about actually beyond Ethereum, what is then the space looking like? And I'm sure we also have many points where we can take inspiration or lessons from other types of setups. So we'd love to hear from you about generally in Web3, where are we learning from?
So first of all, we are learning a lot of stuff that we shouldn't do, and that's very, very useful, right? So Terra is a good example of this situation where it makes it painfully clear that economic sustainability is very, very important. You need to achieve some form of economic sustainability if you want the system to be resilient. And resilience is one of the key properties that blockchain, in my opinion, need to have. But then there are a lot of examples of very good ideas that maybe were missing some technological breakthrough. They were a little bit too early. So the Internet of Blockchains, Cosmos and Polkadot, the interoperability across blockchains, across layers that are functionally independent from each other but connected. We think that's super interesting, and with our hyperchain we really invested a lot of effort there. And in particular, we are working on something called Hyperbridge, which we think is a better way of creating this Internet of Blockchains. Hyperbridge is essentially, again, at a very high level, not too technical level. They rely on the fact that all the layers that are built on top of the same zk rollup, they can share, and they should share the same zero-knowledge circuit. And this means that any proof that is made in any of these layers can be immediately trusted by all the other layers. So you can create this many-to-many trustless generic messaging system that can underpin a lot of stuff. The simplest is a bridge, but in general, it can underpin some form of asynchronous composability across the layers. So you can have, simple example, you can have a system in which you deploy assets in layer A, where you have Aave smart contract, and then you draw a loan in layer B that you use for something else. And this is something that can be implemented relatively easily with this infrastructure. And again, we're super excited to see what people will come up with once they have this tool. And when we started to look at this problem, we were heavily influenced by the Cosmos and the Polkadot design. We first of all, we thought the general idea of an Internet of Chains was super interesting, and then we looked at how they implemented it. And at the time, they rely on some form of consensus to coordinate these chains. It's a good design, but the relying on validity proof is a strictly better design. It's faster, it's cheaper, is more secure, and so in that sense, hyperchains, or in general fractal scaling, is an evolution of many of the design. But we are building on shoulder of giants, so it's great to have been able to observe what was working well in those instances and what we felt we could improve by using a slightly different technology. So there's a lot of learning that comes from there. And in general, there's a huge amount of innovation in many of the other chains. I mean, the focus on very low level of latency is very important, and it's going to be very useful in the future. There's a lot of innovation around the data availability layer that we definitely would like to learn from. There's a huge amount of super smart teams that are doing great work there that we are kind of observing and trying to figure out who to partner with, what to adopt, or whether we need to develop something ourselves.
Absolutely. And I'm so glad that you mentioned all of these topics. There's so many concepts to explore, which we will cover today in the Multi-Chain Infrastructure Summit, right? Across, like you mentioned, interoperability, even like data availability as kind of one of the modular functions, and then going cross-chain and some of the parts that will make developer and user experiences much better, such as account abstraction with different types of middleware or smart contracts. So we will be covering all of these topics, and this is a great introduction and also deep dive into zkSync for us to kick off this multi-chain infrastructure summit. Thank you so much again, Marco, for your time. It's such a wonderful session.
Thank you for having me. It was a great pleasure.